Today we are going to discuss about the typecasting in a Java. What is the typecasting in a Java? So I will write each and every point about the typecasting. What is the typecasting? So topic is typecasting in a Java. In Java. Okay. What is the typecasting? So typecasting is nothing but typecasting is nothing but converting one type value into another type. That is another type. That is called typecasting. Okay. In Java, there are two types of typecastings are available. First one is the implicit typecasting. Second one is the explicit typecasting. First one, implicit typecasting. Implicit typecasting. Second one, explicit typecasting. Explicit typecasting. Okay. So what is meant by implicit typecasting and explicit typecasting? I will explain. So before going to the implicit typecasting and explicit typecasting, I will write one example, then you can understand in better way. So this is my Eclipse VS Code. This is my VS Code. I will create here one file that is a test.java. Okay. Main method. Suppose I write here one char equal to not char a equal to or a variable or a character into integer. Sys out a. What output I will get? 97. Okay. See 97 or I will write here a equal to, then you can understand better. Control C a equal to 97. But this is a character. This is an integer value. A. It is an integer variable. Then how we can assign the character variable to integer? Means someone is converting the one type value into another type. Correct? So that is nothing but the compiler. Who is doing this task for us? Compiler. Okay. So implicit typecasting. Here, compiler is performing the implicit typecasting. We are not responsible for that typecasting. Compiler is doing automatically that typecasting. That's why it is called as a implicit typecasting. So I will write here one point. Here, compiler is responsible for this typecasting. Okay. The another point, sorry, the another point about the implicit typecasting. Whenever you are saying the lower data type value into a larger data type or greater data type value, a greater data type, then it will perform automatically. So I will write here one point. Whenever we are assigning lower data type value, lower data type value to greater data type, then it will perform automatically. Okay. Next point about the implicit typecasting is the programmer or means developer or anything anyone means that has knowledge about a Java, they are not responsible to doing this typecasting. So implicit typecasting is performed by the compiler. So programmer is not responsible for this typecasting. I will write here programmer is not responsible for this typecasting. Okay. In Java, implicit typecasting is also called as a upcasting and widening. So I will tell you what is upcasting and what is widening. It is also called widening and upcasting. Okay, upcasting. Another point about implicit typecasting is it is always a lower data type to greater data type. Whenever we have to assign lower data type value to greater data type value, then it will perform automatically by the compiler that we already seen in previous example. So another example I will write. Suppose I will write here byte. I will write here one variable that is the int type, int a equal to 10. Can I assign the a variable to b? It is a b, or I will print the b value. See, here we'll get the assignment to variable b has a no effect. Sorry, here a. Okay. See, we get immediately a type mismatch error. Cannot convert from int to byte. Int require the 4 byte. Byte require the 2 byte. Okay, or 1 byte. I think 1 byte. 1 byte is required for the byte in Java, and we can't assign the 4 byte value into 1 byte. Okay, that's why implicit typecasting is unable to perform by the compiler. I hope you are understanding. I will write here one diagram. First one, byte. How many byte? Byte require 1 byte value. 1 byte size. We can say size. Okay. Short. Short require 2 byte. After that, int, int, long, float, double, short require 2 byte, 4 byte, or I will write only the 4. You can understand. 4, 8, again 4. This is a 8. Okay. Here, char require 2 byte. 2 byte. Byte short, int long, float double. So remember this diagram. This is going from the lower data type value to greater data type. It byte require 1 byte, short require 2 byte, int require 4 byte, long require 8 byte, float again require the 4 byte, and double require the 8 byte. So this is a different internally. This is a different float and double. That's why then you have one question like long is a 8 byte, again float how is a 4 byte. So that is the question. But internally float is implemented differently, and integral data type is implemented differently. Okay. So whenever we go from lower data type value to greater data type or bigger data type, that is called as a widening or upcasting. Means we are putting the lower data type value into the bigger data type. That's why it is called as upcasting. So I'll write here from this direction to this direction, that is called as a widening or upcasting. Here the important point about this, suppose I write here lower data type like short s equal to 10. Okay, we can assign into the int easily. Yes, I equal to s, correct. That is s, no, I value for I. We will get output I equal to 10. Okay, fine. But when we assign, or when we are assigning the 10 into the short, and again the yes means 10 into the integer. Okay, the size of a int is a 4 byte, the size of a short data type is a 2 byte. That's why we are not losing any information. We are getting an actual output. What value is given in the short, and we are getting only that value in integer variable. Like in integer variable, we are assigning the s, means s value is 10, is putting into the I variable, and we are printing to I. That's why we'll get here 10. Okay. But when we are doing this type of a conversion in uh, explicit typecasting, that time we are losing the information. So that's why we are writing here, or you will write here. I will add one point here. Okay, what happened? Okay, I will write here one point, that is there is no chance in implicit typecasting, implicit typecasting to lose the information, to lose the information. Okay. So Implicit typecasting is done. Second one is a explicit typecasting. Explicit typecasting. So first point, for example, you can understand here uh, byte b or int I equal to 10. Okay, byte b equal to I means we are getting the compile time error, type mismatch, cannot convert from int to byte. Okay, because the byte size is a 2 byte, we already know that, and that's why we have to write here byte. Okay, then we are not getting any error. Okay, this is a warning only. B C B10, or if I put here equal to only C again, 10 B equal to 10. Okay, I will write here one again 130. Then what output I will get? I want to show you. I will get 126 only, minus 126. So how 126? Because I pass here 130, but I am getting only minus 126. So in explicit typecasting, when we do the explicit typecasting, there is a no role of a programmer. We are explicitly doing this, means we are adding here, convert this I value means integer, into lower type, means lower means from higher data type to, we are converting the higher data type value into the lower data type value. That's why it is called as a downcasting or narrowing. It is called as a downcasting and narrowing. Here in explicit typecasting, there is a no role. There is in explicit typecasting, programmer is responsible to do typecasting. Okay, there may be a chance of losing information. I pass 130, but I get only minus 126, means we lost our information. So I can write here, there may be a chance of losing information. Whenever we want to convert bigger data type value into smaller data type, that time explicit typecasting is required. Explicit typecasting is required. Oh. Another example we will see, that is, for example, double d equal to 130.123. Okay, then int I equal to D, or I will write here int sys out I, or I, sorry, I get, or I will get only 130 output. I'm not getting 130.123. See here, I'll not get, I get only 130 output. If you want to see from scratch, okay, then share 130 only. Means there may be a chance of losing information. Whenever we do a typecasting with respect to floating point, then and we are converting that floating point data type into the integral data type, then we will not get any decimal point value. Okay, remember that, will not get any decimal point value. That is the point. So another is, note here, whenever whenever we do typecasting with respect to floating point value, floating point data type into integral data type, then we lost the value after decimal point. I will copy this image. Okay. Remember only this image. Whenever double to float, float to long, and int, long to int, and int to short or byte. Whenever we go in reverse order, that is called as a, or I will write here one arrow for your simplification. Sorry, I will write here. Okay. Whenever we go to the this side, that is called downcasting, downcasting, and narrowing. For this, I'll put here. So remember this point. From left to right, it is called as a widening or upcasting. From right to left, it is called as a downcasting or narrowing. So that's it. It is not that much difficult. So that's why I'm not spending that much time on this topic. So this is a important, but you can able to understand this diagram. So I'm telling this. So topic is important: implicit typecasting and explicit typecasting. I hope you all understand the what is a typecasting in a Java. If you have any query about the typecasting, then inform me in a comment box. Okay.